students, from today we are going to start a new subject, that is telemetry principles, and that is the part of 7th semester electronic instrumentation engineering. So, before we start this, first of all we go through the syllabus of this telemetry principles, but before starting that I want to share one very practical view that is directly related with the practical word, that whenever you are talking about the telemetry, it is always related to the instrumentation part, as whenever you are taking any measurement from any remote location or that location which is not accessible, you required some specific kind of arrangements, because you cannot go everywhere to take the measurements in the remote locations. That is why this particular subject came into the picture, and according to that the syllabus is designed. In this particular telemetry principles, you have basically 5 units, and the very first unit is about the introduction of the telemetry system. In that particular introduction, you go through the different kind of blocks, classification, the factor which influence the telemetry system designs, all about that. And after that, in the second, third, fourth and fifth unit, you are going to study about the various blocks, various systems, various components related to the telemetry principle. So, we start from the very first unit, and as you can see this particular example in this diagram, that is directly related with the telemetry principle. As you can see that whenever a aeroplane is in the atmosphere, in the upper atmosphere, as you all know that aeroplanes are flew into the stratosphere. So, at that place there are many parameters on the plane on board that is required to measure all the time during the flight, such as the temperature, outside environment, inside environment, the pressure which is maintained in the cockpit and the other part of the plane, the working of the various systems such as wheels of the aeroplane, the wings, the tail of the aeroplane, and these all data are going to collected at aeroplane by the onboard data acquisition system. You can easily see that you have to find out this pressure, temperature, flow type of various physical quantity, and to measure that quantity you required some kind of sensors. So, for telemetry system the first requirement is that sensors. Similarly, also the system data, that system data here I show you that AR INC 429 CAN etc, that is specially designed system data for the onboard systems of the aeroplane. So, this is the remote location part. After that remote location part, that data is going to be transferred through the antenna of the particular aeroplane towards the earth station. So, in a telemetry system you can easily see one point, that there are two parts, first is airborne system and second one is particular display computer, where the place that is earth station. So, this is the simplest kind of telemetry example in which you can see there are two parts, one is that is remote location on which you are placing the sensors or transducer, and second one is the particular area on the earth which is going to take that complete data and going to process that data, going to record that data as per your requirement. Similarly, we are going to start with this definition of telemetry. So, in this point you easily understand that the word structure of telemetry. Basically, telemetry come from the two Greek words tele and meter, and here the tele means remote, it means remote place, and meter means measuring. So, it means telemetry means measurement of a distance or a remote location. It means whenever you are talking about the telemetry, there we have some specific point which are directly related, that where we are going to use this telemetry, that 2 points. First one is when measurand is at distant location, when your that particular point which is located at a remote location, such as if I can give you another example of the glacier monitoring system, you can easily understand by that that glacier are situated on the very remote location in the Himalayan region, and the institutes or the agencies or authorities which are measuring the condition of that glaciers are continuously monitoring the status of that glacier by using some sensors. Now, throughout the year it is not possible for any person or agency to stay there on the glacier to record the data. So, what they are doing, they are actually placing some kind of sensor unit or your telemetry unit at that particular glacier, and in the some time span they are going there and changing their batteries or going there for the maintenance of the system, and remotely the data is coming from that particular data center to the earth station through various means of propagation. So, that is our first point where we can use telemetry, that when measurand it is distant location. Now, second point, that when measurand is inaccessible, means you can easily see that in some industry there are some places which is very hazardous to the person or the living things. So, at that position we have to measure the certain parameters such as temperature or pressure or flow of the liquid or something else, and in that condition it is not possible for the person to stay there to take the measurement. So, we are placing some kind of sensor or transducer there, and that is particularly collecting the data and giving us. Here one is clear, point is clear, that that particular point is inaccessible. So, the telemetry principle or telemetry system is going to directly help you about the distant location and the inaccessible point. Then the basic step, when you are talking about the basic steps involved in the telemetry, then very first point is coming, and that point is conversion or converting. That particular point is related to the conversion of physical quantity into the electrical signal. As you are measuring the temperature, you have to convert that data into the electrical signal so that it can be processed. So, for that conversion process, basically we are going to use transducer or sensors. It means we are going to use some kind of transducers or sensor for the particular measurement of a parameter, that is physical parameter. And as per the definition of transducer, you can easily understand, because this is a subject of instrumentation engineering and you go through this transducer part in the starting of your syllabus, that in transducer is a device which is going to convert the physical quantity into the electrical quantity. Now, after converting that, you are going to transmit that particular signal via a channel, and that channel may be a wire or wireless. You can be use some kind of wire or physical connection between the two places, or you can use the wireless medium. And at the receiver part, you are going to perform this reconversion process, as you have to convert that data as per your requirement, whether you are going to record that data, where you are going to wherever you are going to particular make any analysis or going to make any type of calculation on that particular data. So, these are the basic steps which are involved in the telemetry. And here one point is very clear, that I am using here word that transducer and sensors. So, always as you are a student of instrumentation, you know one point very clearly, that all transducers are sensors, but not all sensors are transducer always. That point is directly related, because this transducer is the particular device which is going to convert the physical quantity into the electrical quantity. Sensors is also doing the same, but sometimes these transducers are two types, that may be a primary or secondary transducer, and as per the definition of transducer you can easily understand that transducer is going to convert the one form of energy into the another also. That is why all sensors are counted as transducer, but all transducer are not sensors. So, ये आप इस तरीके से आप इसमें you can easily understand that. So, now going towards the basic block diagram of the telemetry system, you can easily understand these points. And when we are talking about the telemetry system, as per our example in the first slide, you can see that there are three places. First one is sending end, second one is the channel, and third one is the receiving end. So, when you are talking about the sending end, that is the end which is located at the inaccessible situation or the remote location. In this particular sending end, we are having a transducer or a sensor, a signal conditioner, and a transmitter. These all three devices are going to make a combined sending end, or we can say that transmitter of the telemetry system. After that, in the signal transmission medium, you can easily understand 2 points, that it may be a wire or it may be wireless. It may be wireless, because you can easily understand these 2 points, that when you are using some kind of coaxial cable or twisted cable or optical fiber, then it means that is a wired telemetry system. But when you are using RF or EM electromagnetic waves for the transferring of data from sending end to receiving end, that is called wireless telemetry system. Similarly, at the end you are using this sending end one point, that is transmitter. In transmitter you are going to perform some specific kind of exercises, that are some kind of amplification or modulation or signal conversion, that is going to be discussed in the next slides. In the receiving end, we are going to perform just a reverse process of this transmitting end. As you can see that if there is a transmitter, here is a receiver. In transmitter you are performing the modulation, so at the receiver point you are performing the demodulation for the same signal. Then you are going to again towards the signal conditioner part, because this signal conditioning unit is going to play a very vital role in the telemetry system, as it is going to prepare the signal as per the requirement of the system, or it is making the signal compatible to the system. That is why these signal conditioning unit are required on both sides. In the receiving end, the last point is end device, and that end device may be a recording device, that may be a display device, that may be a calculating device. So, that is as per the requirement of your system. So, now we are going to discuss all these particular parts one by one in details. So, in the transmitting or on the sending end, we can see that first one is transducer and sensor. So, the transducer, that is going to convert the physical variable into an electrical quantity. Here you can understand one point, I am talking about the electrical quantity, not about the signal. Here I am talking about the electrical quantity. basically transducer or sensor going to convert the physical variable into an electrical quantity, and that electrical quantity is going to represent the complete changes in the physical parameter, such as you are going to use LV dt for displacement. LV dt is a linear variable differential transformer, and that is used for the displacement measurement. Similarly, if there is some kind of flow of the data, or we can say that flow of some physical quantity such as flow of air, flow of liquid, for that you are going to use ultrasonic sensors to calculate the flow. Similarly, for the pressure measurement or for the temperature measurement, you can use the Burden tubes or the RTD thermistor thermometers respectively. So, this is about the transducer and sensor. So, when you are talking about the transducer, transducer is that unit that converting the physical variable or physical quantity into electrical quantity. Now, second point, that second point is signal conditioner. Signal conditioner first, I here mentioned the signal conditioner first as this is the side of transmitting or sending end, that is why I marked this particular point signal conditioner 1. That signal conditioner 1 is now going to convert this electrical quantity into the electrical output, as the next part or the next part of this system is directly going to work on the electrical signal, but you are getting the electrical quantity, and for making that electrical quantity compatible to the next element of the system or as per the signal form or the signal magnitude, it is required that we condition the signal before providing it to the next end. Then the transmitter part, this is the transmitter part. In transmitter, the transmission of electrical signal to receiving end through communication channel, but that is it not all about the transmitter. Basically, transmitter is going to carry out some basic processes out at transmitter side. So, that processes are modulation, amplification, signal conversion, multiplexing. These are the basic steps which are going to be, or basic processes which are going to be carried out at the transmitter side. So, you can study all these processes one by one, and the first point is modulation. Now, what is modulation? You already studied this particular part in the communication systems. So, I am again going to recall that particular part because it is required here, that modulation means you are going to modulate the carrier signal as per the message signal, because the data which is coming from a transducer or signal conditioner, that is your main data signal or information, and that information signal is having low frequency, and because of that low frequency it cannot travel to the distant place, and in the telemetry system it is required that you take the data at the remote location and then send it to the next point. So, to convert that particular low frequency signal into the high frequency, low frequency signal into the high frequency signal, it is required we use modulation. In modulation we required two signals. First one is baseband signal. That baseband signal or information signal or electrical signal is of low frequency. To modulate that particular signal, we required a carrier signal, and that carrier is a radio frequency signal, and radio frequency signal, that is a high frequency carrier signal that is coming from a RF oscillator. We are placing these both signals at the modulator part, or we can say the normal multiplier part, and then we are getting the modulated signal, and that modulated signal is going to be amplified by using this RF power amplifier, and that power amplifier is going to convert the signal as per the system, or amplify the signal as per the system requirement. So, this is about the modulation. Also I want to give you a crisp knowledge, and that crisp knowledge is about that types of modulation, and in the types of modulation you can easily understand one point, that there are certain types of modulation, and that modulation types are continuous wave modulation and pulse digital modulation. When you are talking about the continuous wave modulation and pulse digital modulation, there are various kind, as in continuous wave modulation you are using sinusoidal waveform as a carrier, whether in the pulse modulation you are using the pulse signals for the modulation purpose. Then these continuous wave modulation is divided into amplitude modulation or angular modulation, and as angular modulation is further divided into frequency modulation and phase modulation. All you understand about one point very clearly, that in the amplitude modulation the amplitude of the carrier is going to be changed or varied as per the message signal or the baseband signal. In frequency modulation, frequency of the carrier is going to modulate, and in the phase of the carrier signal is going to be modulated as per the message signal. Similarly, in the pulse part, the pulse signal is going to be modulated, and as per the pulse amplitude, duration or position, there may be pulse amplitude, pulse duration and pulse position modulation. And in the, if you are going to directly convert that analog signal into the digital one, that it will become pulse code modulation. So, the second part in this particular sending end, that is amplification. You can see that in amplification process, amplification is the process of raising the level of the modulated carrier to a high value, so that it can be cross over the transmission distance. That is the proper requirement of amplification in the telemetry system. Then the signal conversion part. In the signal conversion, it is the process to converting electrical output in the electrical signal, which is compatible to the next element of the system. So, in the last part we are going to discuss about the multiplexing. Basically, this is also a very important part of a transmitter, and you can easily see that in the multiplexing part you are going to share a single channel for the n number of inputs, because you cannot restrict the number of sensor at the remote location. There may be a change in temperature, there may be a change in pressure, there may be a change in something else physical quantity, and you have to going to measure all that physical quantity at the same time. That is why there are a number of inputs there, but from that transmitting end to the earth station or to the receiving end, this is the receiving end, this is the transmitting end, you can see that you are going to use a single channel, and that single channel or one link is going to be required for the system. So, in the multiplexing part, what we are going to perform, we are going to use this single particular channel for n number of inputs, and as per the basic criteria of this multiplexing, you can use frequency division multiplexing or time division multiplexing. Actually, in frequency division multiplexing, you are going to devise this various frequencies into the completely available times to the different channels, whether in the time division multiplexing you are going to use the complete frequency band for different channels one by one. It means for the in the frequency division multiplexing, the complete system is available for the system. So, this is all about the particular summary. If I can consider this particular summary, that in summary part, in this system. Thank you.